purpose of this video is to go over number 37 on 4.5. And the thing that's tricky on this one is the algebra. The concept's the same. So we want to find the minimum amount of paper we need to have this drinking cup. So if I have a cone-shaped drinking cup, there's three things on, there's three measurements. We have the radius, the height, and the lateral length. And the volume is 1/3 pi r squared times the height. And the surface area is pi r L, where L is the lateral surface or the lateral distance. And L is this distance here. And by using h and r, we can find that as r squared plus h squared is L squared. So L is the square root of r squared plus h squared. So that's going to come in later. We want to find our drinking cup to have a volume of 100 centimeters. So I have 100 equals 1/3 pi r squared h. If I solve for h, I get the height is 300 divided by pi r squared. So that's what the height is. Now, if I write my surface area, this is the function I want to minimize. I have pi r L, but L is the square root of r squared plus h squared. The purpose of solving for h in the volume function was now that I got h as a function of r, and if I plug that into the surface area, my surface area function will be only a function of r. So surface area is pi times r times the square root of r squared plus 300 divided by pi r squared. That quantity is squared. Now this function is super ugly to differentiate, and that's what we'll need to do to find the minimum. So the little trick we can do is if we square both sides here, the minimum of a function that's being squared is going to be the minimum of the original function. So we're just going to let's call s squared equals the surface area squared. So here, let's just call it s, is the surface area squared. So s in this case would be pi squared r squared times r squared plus 300 squared. And that would give me 90,000 divided by pi squared times r to the 4th. And I'm going to distribute that. Sorry. My little helper here is not cooperating. So I end up with s is pi squared r to the 4th plus 90,000 r squared, or sorry, 90,000 divided by r squared. Right? If I distribute that through. Now this function is so much easier to differentiate. So I take the derivative with respect to r, and I have ds over dr. And then here I'd have 4 pi squared r cubed plus 90,000 times minus 2, so that's minus 180,000 divided by r cubed. This is what I want to set equal to 0. So if I multiply through by r cubed, I end up with 4 pi squared r to the 6th minus 180,000 equals 0. Solve for r. So I have, in this case, I'd have r is 180,000 divided by 4 pi squared. And then if I take the 6th root of that, that gives me the radius. So 180,000 divided by 4 gives me 4,500. So this is the 6th root of 4,500 divided by pi squared. That would give me the radius. And now if I go back up to my work up here, I had this h in terms of r. So h is going to be 300 divided by pi divided by r squared. So if I plug what r is in here, I can solve for h. And on Wiley, you should be able to plug in, here this would be the cube root of 4,500 divided by pi squared. You should be able to plug this in. I know it's not the prettiest representation of h, but it gives it to you that way. If you had a problem like this on an exam, you'd be able to do an approximation. If you clean this up, you can clean this up by algebra. You end up with 2 the cube root of 75 divided by pi. So you could go about that. You could also clean this up and get a little bit nicer looking number, but again, if you're plugging in a Wiley, this should give you full credit and this should give you full credit. And something like this on an exam, you could do a decimal approximation, just plug it in your calculator and get a decimal approximation for it. If you have any other questions, please let me know. Sorry for the crying baby in the middle of the lecture.